Many and probably all of you have endured a long day of sessions, so kudos for having the appreciation to make it through one last session with the importance of this discussion. I'm sure most of us are anxious to slide into happy hour, but honestly, this is happy hour. You're already there. So you ask, where is my suit and tie? So you're familiar with the dark web, but how better to speak to the dark cloud than through a black hoodie? And this happens to be security attire anyway. So if there are any bad guys or gal actors out there and you're looking to pick up some tips, you have to get through this first. All right, jumping in. Normally, I would take this opportunity to go over some logistics with the session, but I'm going to hold on that until after the agenda, and you'll see why in a minute. So setting the stage, we'll get through some introductions. I'll extend that with putting some attention to the security team and why that's relevant for this discussion, and a little refresher on the synopsis of this session, which sets the basis of what we're going to be talking about. We'll start then with cloud well-architected and best practice principles. These are material, actionable steps you can take to secure a cloud foundation and some of the hardenings associated with that. Then access management, intentionally a looser term that's a bigger umbrella term for some multiple components that make up a bigger space here. Data protection, which should be self-explanatory. Observability, things like traceability, auditability, logging, monitoring. DevSecOps, which is securing the SDLC, securing DevOps. To this point, most of what I've been talking about, if you think about the three pillars of people, process, and technology, most of these things to this point have been technology-based. The governances, responsibilities, and culture will speak more to the people and process side of it. And then in closing, one of the main goals of this session, so how does all this translate to ensuring that we have a secure overlay to Iris in cloud? Okay, setting the stage. First, quickly a little bit about myself. I've been with InterSystems for almost 2 years now, previously at Wolters Kluwer and Nuance, a subsidiary of Microsoft. I mentioned that mostly because all of that has been a focus in healthcare. Title-wise, Cloud Security Architect, member of the Security Architecture and Engineering team, which is this symbol here. And I mentioned that. We're going to go into that in the next slide as to why that's relevant for the discussion here. More importantly, role-wise, helping to guide cloud security posture, vetting InterSystem offerings to cloud, and fronting various kinds of security requirements, architecture, and deployment assessments, and helping to influence and guide governance and policies, the people and process part of it, and also fronting threat monitoring, observability, incident response. I threw this in here, previous experience, just to call out some expertise from a strong engineering background. The relevance of that is I've worn numbers of different kinds of hats that are similar to the varied kinds of roles that operate in cloud. So there is the appreciation of the interests that other roles bring to operating in cloud, and understanding that there's a balance between the security practices and efficiently operating in cloud. So the security team. So the key here is establishing security practices and being an enabler of protecting customers and InterSystems from threats. And I also extend this as an enabler of development, operations, and release in cloud as well. With that, the team brings over 100 years of experience, multiple kinds of advanced degrees, multiple certifications, and across the team, we're subject matter experts in a lot of the relevant areas here: Iris, cloud, DevSecOps, penetration testing, and red teaming. Okay, so the refresher of the synopsis, why we're here. So cloud is unparalleled as a business enabler. This is largely through self-managed resource ship, but at mass scale and worldwide geo-reach, with the caveats that it's due to looser allowances and greater freedoms. It's this last part that has the risk of making cloud the wild, wild west. So here we're talking about the kinds of things we can do to tame that. The two strategic takeaways that I'm hoping you'll get from this session: first, understanding the material actionable steps you can do to secure cloud, or that InterSystems is doing those things. Second, the appreciation that there's confidence of assuring that secure overlay of Iris offerings in cloud. So as a customer of Iris offerings, you have the confidence that it's in a secure environment. Okay, so the kinds of threats that we're protecting against in cloud: there's a bigger landscape that has to be managed, the increased risk from that, typical supply chain attacks, the development and release pipeline and third-party open source components, zero-day attacks, which are same-day attacks that are unknown vulnerabilities that don't yet have defenses established, and then a catch-all cloud attacks for all the typical kinds of vulnerabilities. And then I extend this to include protecting from ourselves, taming the wild, wild west piece of it. With that, I am going to throw all this content at you at once, which is going to seem overwhelming, but that's the goal because it is overwhelming. So all of this. Least privilege, one of the biggest challenges, least privilege tends to be a resisted security, a resisted component to security culture. And least privilege is one of the biggest components of security because it can be a stepping stone and an enabler to getting access to a lot of these other threats and vulnerabilities. Security misconfiguration: this is things like using default security groups that have wide open ingress and egress, in and out traffic, or using security cloud resources that have a default security policy that has weak TLS encryption, like TLS 1.0. Unfortunately, cloud doesn't really come with a secure posture like you might think of with SE Linux or something. You can't select a secure cloud posture. A lot of that responsibility is on you. Inventory drift, orphan resizing, out of control costing. These can be security risks because though you may think they're orphan, they can still be enabled with the right kind of compromise in the rest of the system. They can be jumping points, re-enabled, and used to implement threat with other kinds of contexts. Oversizing resourcing, also with the right kinds of compromise. These kinds of machines can be used with higher compute for things like brute force and redirecting brute force outside of your cloud deployment. Lack of awareness, or with awareness, the diligence is to apply these security best practices, including environments like POCs and sandbox, where you may not traditionally think it's as relevant. And it's not necessarily because it doesn't contain customer-sensitive data. However, you can still have these same kinds of vulnerabilities. They can again be used as jumping points in brute force attacks. They can be used to enable lateral movement to the sensitive accounts. So they're also important to protect. Security comes later or not at all. Lack of shift left. Shift left is a security concept for transparency of security as early in the development process as possible, including when you're conceptualizing architecture and design. Lack of annotating resources, self-describing resource naming. This is part of governances. Unclear roles and responsibilities, which we'll also dive into. And then the right kinds of differences of controls of access in the different different environments, particularly as you start to promote releases to external-facing environments like user and production. They need to have different concept of least privilege and role access. Looseness of identity management. This is numbers of things. Tendency to use administrator or like root user in Linux. Using an Uber shared account, which promotes sharing credentials and most privilege again. Storing credentials in clear text or passing credentials in clear text. A lot of things there. Then there also tends to be there's the tendency to just expose wide open external access. It's easier to do rather than trying to understand specifically what the specificity is of your in and out traffic. Just leave it wide open. And then I think, in my mind, the most important aspect here is alignment of governances, the guardrails, and the policies, the people and process of part of this. If you don't have this, then it doesn't matter what technology you have or can implement it if you're implementing the wrong way or not at all, or not in a consistent manner. Okay, starting with the cloud well-architected best principles. All of the cloud vendors have a set of well-architected pillars. Though the cloud vendors may use different words, they still all have a common pillar theme. That is cost management, cost efficiency, operational efficiency, reliability, performance efficiency, sustainability, and security. And of course, we're going to be focusing on the security pillar piece of that. That's a lot of things like account structure, identity management, detection, data protection, isolation, integrity, confidentiality, availability. Next is as part of the account structure, well-architected environment. This is an organized organizational topology that has planned organizational unit or management group branches, one of which is a security branch that has an audit account for centralized aggregation of security kinds of logging activity events and centralized logging. Next is an infrastructure organizational group for horizontal cross-cutting kinds of services. And then there's a workload branch that contains different kinds of account purposes, like sandbox, development, test, staging, and production. One of the biggest, I think in my mind, one of the biggest components of security is the concept of defense in depth. So if you think about an onion and peeling back that onion, it starts with the cloud edge, which is typically the responsibility of the cloud vendor, but you can also control what resources are relevant at cloud edge. Next is the network edge, network controls, which we'll be diving into next. And then in between the external access and your resources underneath, you have certain kinds of resourcing like application gateways, application network load balancers, web application firewalls, network firewalls. Then the application and endpoint API controls like web server, web application endpoints. Underneath that, the host, the EC2, the virtual machine controls. And then under that is the application itself, in our case, Iris. Then there's the threat intelligence, the observability of all of these things in the onion. Next best practice, encryption and transit at rest, and making sure you're using secure protocols, minimum TLS 1.2. Secure network models, blueprints for reference implementations for network deployment. Multi-tenancy separations. This is making sure that customer deployments separate their resource deployment and data. And then inter-region deployment locality. This is important because you can have additional costs by crossing out a region, but also this self-contains traffic, so it limits the amount of traffic that you have crossing regions. The Center for Internet Security has a bunch of foundation security controls for each cloud vendor, so AWS, Azure, GCP. They all have foundational security controls that define the sets of best practices for implementing security in their cloud environment. Also, ensuring distributed denial of service. There are two key levels for protecting resources here. The network layer, which is layer 4 for protocols like UDP, TCP. And then layer 7 is like the web application, HTTP layer. Lastly, making sure that secrets are stored and used securely. HSM, hardware security module like HashiCorp Vault, using GitLab source control, GitLab pipelines in a secure manner, making sure that secrets are stored securely there, not using pipeline variables in a controlled way. And then various architecture thing, Kubernetes, which is managed container environment. There's a secrets management as part of that. And then using cloud services like AWS Secrets Manage or Key Vaults and KMS systems. The cloud well-architected principles starts with a VPC, a virtual private cloud or virtual network, which is a self-contained perimeter of the resource deployment. So customer deployments can exist in this kind of environment and be self-contained. Underneath this is a subnet deployment model. It's a reference implementation for deploying subnets, which starts with typically a single public subnet that has the role of fronting the external access, and then any number of private subnets behind it that would not have the direct access and will just interact with the public subnet. Underneath that is the perimeter around the subnets, these are NACLs and WACLs, network access control list, web access control list. All of these network policies should be constructed in a default deny manner. First is the access control list. These control access to each of the subnets. Best practice should be to have a separate access control list for each subnet and not having an Uber subnet, which is going to encourage a most level access of rules. Next is the security groups, which is the access control list to specific deployment resources, like the VMs and load balancers. And you'll see that we're starting to peel away that onion in defense in depth. With these policies, recommended practice by various vulnerability, tooling, and cloud, these CIS security controls, is to avoid the use of default access control lists and security groups. They tend to be more access rules, and they promote misconfiguration in case you forget to apply a specific control list or security group with the specificity relevant to that deployment. It will go back to the default, and you could be vulnerable to an open policy. Next, for certain kinds of architectures, like the Kubernetes we talked about, there is the opportunity of using container network interfaces. This is a security mesh that controls network policy for all of the resourcing that it manages. And with this, the key is to avoid loose access roles. The example here, by default, typically this is the easiest path for access, wide open protocol, port, and target versus specificity, specific ports, HTTPS, TCP, 443 and a particular IP, or potentially other private subnets within your network. Also, when you deploy networks in cloud, you're typically given a default CIDR block or an IP set of a range of IPs, which will all be the same, which will be overlap. So a best practice is to have like a governing centralized group that is managing unique sets of CIDR blocks. So when you do have inter-deployment or communication with other environments like cloud to on-prem, you don't have to deal with a more complex network architecture to get around that. Also, best practice is to avoid public IPs for all of your resourcing. The way to do this in cloud, you configure with private IPs, and you use things like private link and private endpoint, which allows inter-resource communication within cloud. Okay, access management. How are we doing on time? Okay, good. So this is that loose umbrella term. I think typically when you think of access management, you think of identity management or identity access management. This is a bigger space now. All of these components work together to control access. It starts with identity access management. This is user and identity account management. Typically, the practice is not to use direct IAM users or groups. So IAM is identity in cloud. So you want to use an identity provider, a user management provider like Active Directory, AD Active Directory. So you have Active Directory users and Active Directory groups. These are either used directly in cloud, depending on the vendor, or they may be mapped to roles in the vendor, like in AWS. And then with that identity, it's controlled through single sign-on. So you're authenticating yourself with your corporate identity management, and then MFA, multi-factor authentication. So again, the idea is to manage the identity through a centralized user store. So this typically is decoupled from the cloud vendor, so you're not distributing, duplicating your identity across cloud. A typical implementation of this is like Active Directory, or potentially you could use an identity provider like Okta, which is that second bullet there. You can still consider an identity provider which can be a vendor that manages any number of these components, but still manage your user identity in a user store like Active Directory. They can work together. So a key is that all access through cloud is controlled through role-based access, not directly through user identity. RBAC is a more of a coarser level of authorization, but there are cases where you need finer-grained authorization, which can be attribute or access controlless. This might be, an example of this might be storage, where you're protecting data, and the clouds have a different way of leveraging role-based access in a coarse way, and then applying like read, write, execute, read, write on individual pieces of data, particularly when you have like sensitive data. So again, the core to all access management, we talked about least privilege. This is where the privilege access module component comes into play. But you want to leverage temporary roles rather than giving users permanent roles. So in AWS, there's secure token service that allows you to assume roles. IAM roles, that's a component of IAM roles anywhere. So when you need a special privilege, you assume that role, and that role has the sets of privilege that are scoped specifically to what it needs to do. This can be challenging to try and figure out what roles are necessary to do work in cloud. AWS, for example, though, has Access Analyzer, where it will assess all of the activity you're doing and tell you what permissions you're using and what permissions you don't use, and then you can use that to create a lesser privilege role, a more targeted privilege role. So in addition to user privileges, resources have privileges. So an EC2, a VM, has a role associated to it. So as the VM is doing activity, it's doing activity on behalf of itself, not on behalf of a person. In Azure, this is managed identity. In AWS, it's a similar cloud role as you would use for users. Same concepts apply, making sure that there are targeted least privilege permission policies that device only needs. And then avoiding using long-term credentials like access keys. You do have the opportunity to take an access key to perform your actions as a way of circling using roles. And making sure there's no use of root account or owner level roles. Like in Azure, you can be an owner. In AWS, root is at the top of the access chain, making sure you're avoiding those accounts. Okay, data protection. Starts with encryption in transit at rest. The mention of pseudonymization and desensitizing, if you're going to move that data out of its protected environment, then you want to make sure that you're not carrying any sensitive information with that. A best practice is to use customer versus cloud managed keys. So when you're configuring encryption at rest, typically by default, it's a cloud managed key. It's much easier, but it's better to have customer managed keys. That way, you control the encryption keys of your data. You can either bring your own key, or you can create customer keys in the cloud. With storage accounts, they also are associated with least privilege access policies. Same kinds of considerations you would do with users and resources. And then you have to be sensitive to compliance controls. This could be like GDPR, General Data Protection Regulation. It's a UK or European sets of controls for protecting sensitive data. California has a similar one. They have particular rules around data retention and regional data sovereignty, which is the locality of the data. And also things like need to use policy, that no one can have access to the data unless you need to use it. Data classification is classifying the data. So like restricted, sensitive, controlled, open, the different level of sensitivity of the data. This supports auditability with compliance. And then lastly, making sure you have auditability of data access. So any of your storage accounts should always have like access logs enabled that's tracking all of the access to data. This is particularly relevant in production and user-facing accounts, as other kinds of roles like operations assume the roles that are necessary to navigate through cloud. You have the auditability of what they're accessing. Observability. It starts from a security perspective. Forensics is a key component. This is the ability to trace events. Particularly, you might think it's incidents, which is the most important use case, but it can be any kind of tracing through cloud. We talked about inventory drift. and orphan resources, the things around forensics will help you find these things in cloud. One more thing with forensics, so that that gives you the ability to track that event end to end. It could be the flow of activity. We say north, south, or east, west. It's the external axis within the system. The east, west is the lateral movement with resources. In order to do this, you have to enable structured cloud logging. This is centralized, desensitized logs. We mentioned that as part of the well-architected environment, having a centralized logging account. In AWS, this means like CloudTrail, CloudWatch, and Access logs, for example. And usually, from a security perspective, when we assess an environment, we'll consider this kind of misconfiguration or lack of configuration as critical, because without forensics, then we can't react to incident response. That's complemented with the structured application logging. So Iris logging is typically surrounded by tools like SignalFX or CoralLogix. And compliance auditing. So this is making sure that from a compliance perspective that you are doing all this logging of the resource use. Alert monitoring. So this is having observability on certain kinds of events in cloud. So, for example, we've had some cases where there were elevation of privilege to an admin level access through accounts. So we can set up alert monitoring in cloud. So in real time, we can be alerted to when someone is doing this activity. There's also alert monitoring through the identity and threat detection tooling, CNAPP, Cloud Native Application Protection Platform tooling like Lacework, that will do intraday and daily alert monitoring of the posture. And then with the observability, the incident response, security operations centers. But one thing to be careful with this, is alert and event fatigue. So there's a lot of volume of this. It's very difficult to weed through it and understand the important events. Typically, you'll have a lot of deployment posture that you understand you have weaknesses, and so you need to weed through those and get through the new events of the day that you're not sure about. So it's one of the challenges is establishing a team that has the resourcing to be able to have regular eyes on this and track the tickets of the issues that come out of this. I mentioned data lakes. This is a type of resource that aggregates all of this material. It's a more efficient way for searchability and querying into the data. The searchability aspect of it, and then part of observability is the tooling I mentioned, like with Lacework. They will do regular checks about those cloud security control best practices. DevSecOps. So we're getting to the Iris piece shortly. So hang in there. DevSecOps. So this is static application software testing. This is implementing tooling like check marks for software quality and various kinds of vulnerabilities. The OWASP kinds of security checks and check marks for third-party component, both which should be tightly integrated into a continuous integration pipeline, so that you're checking these things on a regular build basis. And then dynamic application software testing. This is testing the API endpoints in the runtime. This can be typically done ideally in continuous deployment, but is usually separated. Then also penetration testing, red teaming, supply chain hardening. This is vetting of third-party and open source software, best practices to create software build of materials, signed for the integrity of it, secure pipeline credential management, avoiding credentials in code and securely managing those credentials. We talked a little bit about that. Making sure that environment configuration is parameterized, so you have different levels of configuration posture as you're in different levels of sensitive accounts, like development versus production. A key to DevSecOps is automation, avoiding manual steps, and then also making sure you have a best practice branching model, which separates feature, dev, product, and multiple kinds of offerings, so you're not commingling features and running the risk of pushing unintended artifacts into different environments. And then the code signing piece is the integrity of the packaging. I think 2 more to go. Governance is culture, responsibilities. This is the people and process piece of it. Common themes, making sure that you're using multiple cloud provider common denominator syntaxes, particularly if you're releasing into multiple cloud providers, which is the case for InterSystems. So this allows you to have a common way of naming and managing the deployment across cloud, this is through a canonical cloud syntax. And the key here is to make sure that it's self-describing. So the way you're annotating and doing resource naming, self-describing manner, so that as you're navigating through cloud, it's an immediately readable landscape. This can be facilitated typically through centralized naming dictionaries. A key governance component is the topology. We spoke about this already as part of well-architected environment, the planned organizational structure. And then I'll talk about resource naming and tagging in tandem. These two are fairly critical governance items. This is where you can get the self-describing deployment context, a lot of the common themes, but these are 2 different kinds of concepts. They do overlap, but their use varies throughout cloud. So though you may overlap in some of these naming concepts, you typically won't see them together in various places of cloud. The main thing is these facilitate forensics. So it's very difficult to do forensics without having these kinds of policies. It allows organizing resources, and it gives you the ability to separate business criticality, the data sensitivity, the data classification, identifying customer resourcing, which customer is relevant to a particular resource, and they all support auditability, compliance, and ownership. With the resource naming, the example I gave there, so this is a multi-component syntax. The first part is data platforms. It's an application or development team parent umbrella. The second part is a subcomponent or a sub-application context of that, like Fire as a Service. So the data platforms group is the application team fronting this offering. The offering is Fire as a Service. The P is the environment realm. So it could be, here it's production, development, staging, and test. Use 2, that's the region. So this is US East 2. And this, again, is an important canonical semantic. One of the more complex things to understand across cloud is the different ways that they call the regions. So this is a common way to be able to search that across the vendors. VM, this is the resource. And then demo is the purpose of the resource. Last, region management. We mentioned that it's best to have, it's best for everyone to be deploying in a common set of regions, so you're not spreading out in geo and not being sure where everybody's deployed. And then service and security control policies, which are guardrails to how you're using cloud. Culture, it's a fundamental component for security in cloud. Embracing common and shared governances. Part of this is making sure that you have a commitment to regular security sprints and marathons. Continued training, that shift left, the transparency of security in conceptualizing early in development with architecture and design. Security champions, these are delegates of the security team. Security team does not scale for having enough visibility to all the different kinds of offerings. So these are resources that are at the front lines of particular development that are championing all of these culture things. We actually have a guest in the audience here that is one of the security champions, one of our development groups, ICCA, InterSystems, Cloud Core Architecture, manages a lot of offerings to cloud. They are they're committed to security governance and culture, and they are piloting a security champion. This is Xavier here. Thank you. And with that, we are going to give you a security member badge. This is a rigorous security achievement that you need beyond the white one, so we appreciate your efforts. Clear roles and responsibilities. I'll go quickly through this. You can look at the different levels. I'll have 3 different views of this. This is an abstract cloud view. This is an AWS view of it, but the clouds are consistent with this. Basically, it's security of the cloud, which is the cloud vendor, and security in the cloud, which is the customer tenant. This is a more detailed view that the security team put together. It represents the different kinds of as-a-service deployments, infrastructure as a service, container, platform, function as a service, software as a service. All of these have different levels of deployment responsibility, whether it be the cloud or you. And this is a responsibility matrix, so not so much shared responsibility of cloud, but this is avoiding the lack of understanding of roles and responsibilities, standard RACI matrix for the different teams that are involved and the different types of tasks. Lastly, Iris. So how does this translate to a secure overlay in Iris? We're leveraging the best practices. Every deployment is self-contained in their own virtual cloud, their own network edge, their own defenses in depth, their own onion. We're leveraging the best practice, the well-architected subnet model, environment separation. There are separate roles and privileges into production, no direct access management, separation of logging. In offerings that expose public interfaces to the cloud, like Cloud SQL or Cloud Document, which may have direct access, not direct, but would have access into Iris to the super server port. They expose the ability to have customer control whitelisting. You still have all the native Iris controls, all of the access management, enablement of process, and things that have been talked about in the previous sessions. Once you get down to that core of the onion, you still have all of that. All of the offerings to cloud are vetted through security assessments that we talked about with the security team role, protected secrets management, use of all of those best practices, and we have active identity threat detection monitoring for all of these things, for all of the customer offerings, best practices on securing containers, not running as privileged, not running as like root user, host operating system, protections for where the containers run. There's no direct remote access into the machines, no SSH or RDP. This is fronted in AWS, their secure server manager, in Azure, their Bastion host services. This allows operational access into the machine without having to open up ports like 22 for SSH. No direct public exposure. So we've made it to the end. Bunch of references that speak to a lot of the things I talked about, and just surveys. That's it. If you have any questions, thanks. If you have any questions, feel free to come up to me after the presentation. Hit me up elsewhere in the summit. We can make an appointment. You can also contact me directly, firstname.last@intersystems.com. Come take a white pen. You've made it through here, so I think you need two. Thank you.